Good morning, everyone. Again, I don't know if you heard my previous sentence, but welcome to this webinar of Solarplaza. How will AI impact the solar industry? I'm looking forward to a very exciting webinar with lots of information. There is time for you to ask questions, so don't wait. Let's not wait too long and get started with me sharing a few slides. And let me see if I can get the next slide up. And that slide will show us a little bit more about Solarplaza. In case you didn't know or don't know us, we celebrate our 20 years anniversary in 1 month from now. Organize more than 200 solar related events around the world, as you can see on the map. And we have a huge database of about 60,000 professionals around the globe. I'm very excited to have a lot of registrations, a lot of people interested in this webinar. Let's go on to the next slide. Here you see a couple of our upcoming events. Next week, we have a very exciting event in Amsterdam, the future of energy, usually like more than 400 people attend. And then you see other events all across Europe and in North America. Our celebration of the 10th edition of the Solar Asset Management North America event. Good. Topic of today, next slide. Yes, there is various opinions about AI, and they vary from AI is maybe a big fat lie towards the other side. Artificial intelligence is going to be an unprecedented disruption. Now, what does this all mean for the solar industry? We'll have a couple of interesting speakers for you to discuss that. But before we go to the topic itself, some practical notes. There is, of course, for you an opportunity to ask questions, and you can do it through the chat box on the right side, and we will try to answer your questions with the speakers as much as possible, but we can't guarantee that all questions will be answered. We know it's a hot topic, but please send them in, and we'll try to do our best. So technical issues, you can also use that Q&A chat box, and my colleague Bo, who's in back end, will try to help us as soon as possible. And then the presentation slides and full recordings will be made available afterwards, and you will receive an email with instructions within 1 or 2 days. Good. Let's get started, and let me introduce the first speaker. And here you see the agenda. We start with a presentation more in general about the opportunities of AI by Wahbe Rezek. Then we have a presentation by David Moser, and we'll finalize this session with a presentation by Leon Overweel. We will have time for Q&A at the end, but also after the first and second and third presentation, after each presentation, we will have some time for Q&A. We'll start with a poll question. So if my colleague can bring up a poll question to get a more general idea who's in this virtual room. Let's start with the first question. Bo, can you bring that up for the participants?
Hey Edwin, I'm really sorry, but the poll questions are not working technically.
Okay.
I can't seem to get them to work.
Okay, fair enough. Well, let's not waste time and let's go to the first speaker. That is a presentation by Wahbe Rezek. You can see, yeah, that's me. I'm Edwin Coates, founder of Solarplaza. Not so much interesting. It's all about the speakers today. Wahbe Rezek, he is an AI and ChatGPT consultant. You can read more about his CV over here, but please give a welcome. Wahbe, can you hear me?
Yes, I can hear you. Can you hear me as well?
Yeah, I can hear you very well, Wahbe. Just a first question from my side. So when was the first time you got in touch or you learned something about AI?
Well, like you said, I worked at the financial industry at ING, one of the biggest banks in the Netherlands. And in 2019, I became a program manager within financial markets. And within that program, they were already using AI or experimenting with AI to see whether AI can help us with to prevent fraud on financial markets. So in 2019, that was the first time I really got in touch with AI. And after that, I deep dived more into it because I was super excited about the possibilities of artificial intelligence.
Okay, well, let's give the floor to you. Good luck, and please start speaking now.
Thank you. Thank you very much, Edwin. Okay, let's see if I can go through the presentation. I'm not sure if it's working. Yeah, I think it's working now. So welcome at the presentation, the impact of artificial intelligence. Like Edwin already said, my name is Wahbe Rezek. I will not tell you about artificial intelligence within the solar industry, but about artificial intelligence in general. Edwin already introduced me, so I don't need to do that anymore. So let's start quickly with the presentation. First question is, what is AI? Because we hear nowadays a lot about AI. You might hear about many different terms like machine learning, reinforcement learning, NLP models, language models. There are so many different terms that are related to AI. So sometimes you might get a bit confused. And that's because AI is actually a very broad term. It's actually a field with a lot of different applications. But when we look at the definition of AI, the broadly accepted definition, we talk about AI when we mean the ability of machines to perform tasks that typically require human-like intelligence. So machines that mimic human-like intelligence. And you might think, what is human-like intelligence? Well, we talk about human intelligence when we, for example, talk about having a conversation, understanding the other person, but also understanding certain situations and certain scenarios and making decisions. Those forms of intelligence are we always thought about them as human intelligence. But nowadays, we have machines that can show these levels of intelligence, and then we talk about artificial intelligence. So that's what artificial intelligence is in a simple way. And this idea of artificial intelligence already exists for many decades. One of the first persons to really write about artificial intelligence was Alan Turing. You might be familiar with Alan Turing. He lived in the past century and he played a very crucial role during the Second World War. Together with his team, he developed a machine to decode coded messages. And there's also a film made about this, a movie made about this, The Imitation Game. You might have seen it. But Alan Turing was successful with his machine during the Second World War. And after that, after the war, he got very excited about it, about intelligence in machines. And he wrote a paper called Computing, Machinery, and Intelligence. So he was one of the first persons to really write about artificial intelligence. So this idea already exists for a very long time. And also, if we look at Hollywood, from Hollywood, we have already seen for decades movies about robots and artificial intelligence. Actually, robots that became so smart that they took over the world, and often in a doom scenario, but luckily it doesn't have to be like that. So this idea of artificial intelligence already exists for a long time, but probably you have started hearing about artificial intelligence only in the past few years. That's because AI models became much better and showed much better results in the past few years. And this is due to many different factors, but there are actually two things that played a very crucial role. One of them is increased computing power. Nowadays, we have these supercomputers that can analyze big data sets in a very fast time and make connections between different data points. If we look, for example, at ChatGPT from OpenAI, Microsoft is co-owner of OpenAI. They have 49% of the stocks in OpenAI. And OpenAI got access to the supercomputer from Microsoft. And that is one of the reasons why they were able to develop ChatGPT so quickly in the past few years. So that's one factor, computing power. 20, 30 years ago, we didn't have computers powerful enough to analyze big data sets and come up with interesting conclusions. The other part is that we just started developing much more efficient and effective models. Like it goes with everything, like a project you're working on throughout the years or throughout the months, you start becoming better at it and develop much more effective solutions. So in the past few years, we started seeing the first really relevant and useful AI models. And that's why you started hearing more and more about it. But AI is already being used more than a few years, already for almost 10 years, for example, in social media, like Instagram, TikTok, Facebook. In those social media platforms, we see already AI applications for years, where the AI algorithm is trying to understand your behavior and show you only content that the AI algorithm thinks, okay, you will like that or you are interested in that. For example, also in Google Maps and Google search engine, AI is being used for years as well. And also if we look at personal assistants like Google Assistant or Siri on the iPhone or Amazon Alexa, those are personal assistants that use AI algorithms or AI models to understand your question and execute a task for you. But if some of you have maybe used those personal assistants before, you probably know that they were not that smart yet, so they couldn't do that much for you. They could maybe look up the weather forecast for tomorrow for you or set an alarm, but they couldn't do much more than that. So AI applications are being used for years, but they were not so smart yet, and they were mainly on the back end. That's probably why you didn't hear that much about them yet. But you can imagine now AI models are becoming better. We are going to see many more AI applications that are useful in our day-to-day work. So let's look at those expected AI applications in the near future. I have here a list on the screen with 6 fields or 6 sectors where we can expect a big impact of AI developments. Of course, there are many more sectors. I cannot explain you all sectors now today in this short presentation, but I will try to inspire you by giving a few examples from those sectors. So let's first look at those personal assistants. Like I just mentioned, we can expect that those personal assistants will become much better in the next few months and next few years. And those big tech companies like Apple and Google already mentioned that they will release new versions of those personal assistants this year. And those personal assistants will be able to do much more for you. Throughout time, they will learn more and more about you because they have access to your email, they have access to your browse history, they can analyze your behavior, and therefore they can understand you much better. So they are a personal assistant dedicated for you. And one example is that they can take over tasks from you or automate tasks for you. For example, if somebody sends you an email with the question, shall we meet next week? That personal assistant, that AI buddy that you have, will already know whether you want to meet with that person next week or not. And if the AI model thinks, okay, you want to meet with that person, the AI model will already plan a meeting in your agenda or in your calendar for next week. So that is one AI application that we can expect in the next few months or the next few years. And it goes actually so far that there are already people using those AI buddies or AI assistants, and they say that they can communicate so well with them that they started having feelings for them, or they got even in love with them. And this might sound very strange, but this is really happening right now. In the presentation that you see now on the screen, and you will get that after the webinar today, I've pasted a few links or I've pasted a few articles with links to those articles. So if you want to know more about those articles, you can click on those links and then you can read a little bit more about it yourself. And talking about people that fall in love with their AI assistants, in 2013, there was a very good movie called Her. You might have seen it. That's what the movie is exactly about, an AI assistant and somebody that uses that AI assistant and started having feelings for that AI assistant. If you haven't seen that movie, check it out. It's a really nice movie. Let's move on to the next sector or the next field, autonomous transport. We hear already for years about autonomous cars and autonomous transport, and those autonomous cars are already using AI models for many years. Actually, self-driving cars are not even possible without AI models, because you need AI models that can look at the road, look at the environment. Those are computer vision AI models, and analyze what is happening there and make the right decision. But since those models were not that great yet, we couldn't fully rely on those models. However, those models are becoming much better, and the expectation is that we can expect to hear more and more about self-driving cars in the near future. In the US, in California, there are already 2 companies that are experimenting on the road, that are able to hit the road with their self-driving taxis. So there you can order a taxi, the taxi arrives, there's nobody inside, but you can step in and the taxi starts driving by itself. And this is a field that we will start hearing more and more about in the near future. So you can expect also these self-driving taxis, but also self-driving trucks, trams, metros, etc. in Europe and in other parts of the world, probably this year or next year. Next sector or next field is healthcare. Within healthcare, there are actually a lot of AI experiments in the past years. One of the most famous AI experiments is AI within radiology. You might have read about it or heard about it. There have been experiments to see if AI can help us track cancer cells in an early stage. And the results of those experiments are very, very positive. They show that AI computer vision models can look at those X-ray photos and recognize cancer cells in a very early stage, often even better than experienced people within radiology. So what we see now happening is that many hospitals around the world, also in the Netherlands, are either already implementing this or have already implemented this. So this is not even the future, this is now. You see that hospitals are implementing these kind of AI solutions now already. Not to replace experienced people within radiology, but more as an assistant so they can do their work much better and much faster. But there are more experiments also within healthcare, also with robots in healthcare. For example, in elderly houses where boredom or being bored is one of the biggest problems. We see now AI robots being implemented in elderly houses, and elderly people can talk to them. And you might think, well, do they want to talk to a robot? Well, the results are very positive. They show that these elderly people are very happy with talking to those robots because those robots became so good in having a conversation, so you can have quite a natural human-like conversation with them. But there are more examples with robots. For example, also robots with AI intelligence in them that can, for example, clean bathrooms and toilets. And I have here a video in the presentation that I will try to play. It's a short video just to give you a short example of how far robots now are already. You see this robot entering a bathroom. It's a bathroom that the robot hasn't seen before. It's just trained on many different bathrooms and toilets. And the robot is able to open the door, enter the bathroom, and clean everything. So this is how far we already are with intelligence in robotics. And this is being used now, for example, as an experiment in some hospitals around the world. Let's move on to the next slide. AI in healthcare is also being used in the research field in healthcare to, for example, better understand protein structures. And one of the universities that is using AI to better understand those protein structures is Leiden University. Why do they want to understand those protein structures much better? That's because with that they can develop much more effective medicines. So medicines that are more helpful and medicines that are maybe cheaper, but also medicines for sicknesses that we don't have medicines for yet. So also Leiden University in the Netherlands is using AI now to develop better medicines. Let's move on to the next sector, the financial sector. I already mentioned that I was working at ING, and we're seeing now that AI models are being used more and more in the financial sector. First of all, to prevent fraud, to track and prevent fraud, but also to do predictive analysis. I think the other presenters will talk a bit more about that, so I will not deep dive into that. But predictive analysis and AI advice based on financial data is one of the big developments that we are going to hear more and more about in the near future. In the presentation, I have a few articles and also a video from the biggest bank in the Netherlands, ING. In this video, they explain how they use AI for the applications that I just mentioned. Another sector is the global challenges sector. It's not really a sector, but it's more the global challenges that we have now nowadays all over the world. One of the biggest global challenges is global warming and the wildfires that now are emerging every year more and more. And we see now that, for example, Google, together with the US government and some other governments around the world, are using AI models to better predict those wildfires. And by better predicting those wildfires, we are, for example, also able to mitigate them or prevent them. So this is also one of the applications of AI that we can hear more and more about in the near future. It's also part of predictive analysis with AI. And the last sector is the education sector. It's a very important sector. Nowadays, young students can write any presentation or any report with the help of ChatGPT. So you saw that in the beginning, educational institutions or schools were saying you are not allowed to use ChatGPT, but they discovered that they cannot really control it. They cannot check or cannot rely on detection tools to see if something is written with AI or not. So now we see a transition within the education field, and that's that schools and universities are saying, you know what, knowing how to use AI is probably going to be a very important skill for the future, and we are preparing our students for the future. So instead of saying you're not allowed to use AI, we're going to stimulate that. We're going to motivate our students to use AI, but we are going to teach them how to use it responsibly. So that is something that's a transition that's happening nowadays within the education sector. Those were a few sectors to show you the impact of AI and how it is going to change our way of thinking and our way of living, our way of working. Of course, this was a very fast presentation just to give you an idea. There's much more to tell about it. If you want to know more about AI in the presentation, I've put some AI influencers. Those are people that share more information about AI. You can follow them on Twitter or X, YouTube, LinkedIn, etc. And if you are interested in more AI applications and AI workshops, with my company, we provide AI workshops, AI training, AI advice, and AI implementation. So check out our website. Thank you very much. That was my presentation.
Thanks, Wahbe. Very interesting to see this overview of where and how AI is already being implemented. I didn't know that it goes so far back. To me, it feels more like a revolution started only maybe 1 or 2 years ago, but that's maybe related to the ChatGPT launch. There are so many new tools and apps arriving on the market, and all the big tech companies are playing with it. So how to keep an overview of all of this? What do you recommend? How do we see what is all possible?
Yeah. That's a good question. That's a difficult part right now because everything is developed so quickly, and there are so many different schools, companies, governments working on AI development. So it is difficult to keep track of everything, but maybe you don't want to keep track of everything. Like I said, there are a few AI influencers that made this their full-time job. You can follow them. That's what I do as well. I follow these kind of AI influencers and AI institutions. That is probably right now the best way to stay on top of it.
Okay. I'm checking with my colleague if any relevant questions have come in, but so far I don't see any other questions. So thanks, Wahbe. We will please stay within the webinar, so at the end of the show we can follow up with more Q&A. Thanks so far. Good. Our next speaker, if we move to the next slide, I'm glad to introduce David Moser. And David is from the URAC Institute, Technical Institute, has a lot of experience in solar, and he is going to talk more about his view, his perspective on how AI is going to impact in the solar industry. Welcome, David. Can you hear me?
Yeah, I can hear you loud and clear. Thank you, Edwin.
All right. Yeah. Also, a question for you, David. So, when was the first time that you started using AI?
Well, let's say tools like what I will try to explain also in my presentation later, like tools related to AI, like machine learning, neural networks, and so on. I think this is something that is being used in R&D since many years. Sometimes without knowing that we were already using AI. So I would say at least 10 years, but I agree with you that the disruptive character of AI is coming now.
Yeah, good. Well, I look forward to hearing more. Please take it away. The floor is yours.
Thank you very much. So I think that the previous presentation was an excellent presentation to show the disruptive character on AI in several sectors. I will try to give you an overview of what we have done so far, already implemented, but mostly also some food for thoughts of what and how AI could do in the solar sector. So we strongly believe that AI, as we know it now, so generative AI can be a new power player in the PV industry. In fact, it could reshape the solar energy landscape, bring in new challenges, of course, but new opportunities in terms of business operation and efficiency. Before we start, I think it's important, we already touched upon this subject of making sure that we do understand why there is such a, let's say, so high interest now in AI. Because if we broadly differentiate between predictive AI and generative AI, predictive AI is everything that we have done so far, of course, improving a lot. But our interest now is really shifting to generative AI and how this can be disruptive in the sector. So predictive AI can, for example, be in use for energy forecasting, failures detection in smart energy systems. It's data-driven, it relies on models and on machine learning, for example. It's what we've been dealing with for years now. What we really, okay, it takes just a little bit to switch from one slide to the other. So what is coming next and is yet to explore in its all functionalities, at least in the solar sector, is really the use of generative AI. So mimicking creativity. And I think what is really disruptive is the accessibility to everyone. So ChatGPT is very famous because everyone can use it. Any other, let's say, AI-based techniques, you need to be a trained scientist or technician to be able to fully master it. So the transition at the same time of we are not just expecting people to be passive users of generative AI, but it will require the emergence of specialists that will be experts in the field of AI, of course, but also in the vertical field of solar for this specific presentation. And the first question, I will take you through a journey of different, let's say, applications. And the first is that if AI can drive an entire framework. The answer is yes. This is a typical framework, let's say, in operation and maintenance of PV systems, where you do have some sort of prediction and forecasting, you check for outliers, you try to predict a failure, you classify and diagnose, you do an alignment and fine tuning, and then you do a reporting. So how can AI help in all these steps? Outliers detection is a classical example where by using AI techniques, I can clearly understand when something is not going as expected. I can look into failure prediction. So I can try to understand before something happens. So in a preventive way, in a predictive way, I can see if some behaviors will be leading to some failures. And so I can then customize the automated action to make sure that I can act on time before the failure happens. And here comes really the, let's say, the novelty of it is the possibility of using large language models to generate reports that don't have to be standardized. They can be tailor-made for the operator who is looking at a failure in the field. So this report, they can explain what happened. They can explain how the suggested measure to, let's say, to resolve an issue in a PV field, for example, a failure at inverter level or PV module level. And it can explain if the course of action was effective, and it can teach and give some insights for, let's say, future references. So this, I think, is one of the real first changes and disruptive character that AI can bring in, because it can be accessed by anyone, not necessarily someone who is a tech-savvy person. And in this reporting, you can also see, for example, the difference in using different versions of AI engines, like moving from ChatGPT 3.5 to 4, you can already see the benefits of one engine compared to the others, just to demonstrate also that that whole sector is in evolution. And if you are not actively controlling the process, then you might end up, let's say, in having some issues. So this is one way we believe that AI will have a massive impact. So tailor-made reporting for different market segments in the sector. The second part is, of course, AI can become fluent in solar language. So what we have done at URAC is that we have started looking into clustering techniques, for example, so to check if AI can start creating correlation between failures that we see in the field. Just as an information, within a new funded project, Trust PV, we have looked into 200,000 maintenance tickets, and we have looked into the ability of AI of clusterizing cause and effect. But even more interestingly is that you could even have AI agents, so collaborators in your group, they are entirely based on AI. And these agents, they can have different expertise, they can work together, they can execute several tasks to prepare tailor-made reporting. So an entire framework instructed and operated by AI. This is just to give you an example where we have 3 multiple AI agents. They can do full AI operation, and they can let's say go beyond conventional approaches by minimizing human errors, maximizes precision, and streamlining processes. For example, we even given names to these AI scientists. We have 3 at the moment working together. We are, let's say, exploring the possibility of having an AI scientist taking over some specific roles. For example, this is the data scientist that can dive deep into data, looking at partners, predictive patterns, predictive future outcomes. And it can have a continuous dialogue with the other agents, for example, the supervisory agents or the mathematicians agents, and they can interact with each other and run the whole framework based on AI. If we look in terms of level of disruptions, then as I mentioned before, one really positive asset of this generative AI is that the language you use with the AI and the language the AI is using with you is tailor-made to the person who is using and operating the interface. So we put this major disruption ahead for a simple reason. There are several operators in the solar sector. Their own business models and added value rely on very sophisticated dashboards where you can see PV performance, dashboards that takes quite a lot to onboard the system on these dashboards. It takes quite a lot to train the users to fully understand the power of the dashboards. So we believe that companies working in monitoring, for example, of PV plants, but not only, also any company, let's say, relying on information provided through dashboards, should be very careful in what's coming next, because AI could, in most of, let's say, the typical uses for the PV sector, they could be completely bypassed by the use of AI. How come? We have prepared a beta version of a Telegram-based, let's say, chatbot. What does it do, this chatbot? It essentially bypasses completely a dashboard, so there is no need for an user, for example, a user in the residential market or commercial and CNI market, where typically the users are not experts in photovoltaics. So in that specific case, we believe that, offering a dashboard is a cool feature, which might be used for the first couple of days because it's cool to see what is happening, but then that's it. And then maybe people, they even forget about the existence of those dashboards. But by using tools that they use on a daily basis, like Telegram or WhatsApp, they can interact directly with an AI engine, even by using vocal messages. And the AI can look through the dashboards and presents the information in a friendly and organized way. This, of course, can also be used by not only by people who are not knowledgeable with solar, but they can, for example, they need a quick response on how the PV portfolio is working, and instead of interrogating directly the line responsible, they can have an immediate answer by interacting with the AI agents. So we strongly believe that the coming months are set to witness a leap in this type of applications. There will be many companies, there are many companies who are working in the background at the moment, maybe not ready yet to release their new products. But we will see a revolution in the solar sector by leveraging on AI. So just to summarize, I presented some concrete application on how AI could drive entire frameworks from, let's say, more consolidated concepts like looking at outlier detection and predictions to tailor-made reporting for the operation and maintenance sector and advanced automation in monitoring by completely bypassing the needs and the use of dashboards. And with this, I would like to finalize my presentation by acknowledging the two colleagues who are mostly working on it at the moment within my team. And we are, of course, looking on expanding these activities because we believe there will be a lot that can be done in the sector.
All right, David, thank you very much for an insightful presentation. I think before we go to the question from the audience that came in, we can do the poll question. I'll check with my colleague Bo if we can bring it up. Yes, and I would like to ask the audience to actively participate by answering this question. You can share your vote on what do you think and see AI. Is it a threat for your job? Well, not at all, or not for now, but maybe in the future, or for sure, definitely, and maybe it's already affecting your job. So please make your choice, what you think is most applicable to this question as an answer. Interesting to see that is there a threat for your job is almost in the lead. Not for now, maybe in the future. Only a few people see it as a real threat.
Maybe it wasn't convincing enough. Or everyone who is connected is already an active user of AI.
That could also be the case, yeah, that a lot of people are already active users and they see only more work coming from it than... Yeah. Thanks for... Yeah, does it surprise you, this answer, David?
Well, not knowing let's say the audience today is difficult to comment. I would expect if the audience are people working on, let's say, in operation maintenance or in the asset management sector of the solar sector, it surprises me a little bit because my discussion so far with this type of experts is that they are looking at it with interest, but they don't fully understand yet where all the, let's say, the fuss is about. But as I said, it might even be that the audience today, they are all, most of them, experts in AI, and so they do understand that it's not going to be a threat for them. It's actually going to be a huge opportunity.
Yeah, maybe related to this is a question coming in from Thomas Behage, if I pronounce his name correctly. AI can be used in the O&M of PV plants, but what about the design and construction of PV plants? Can it be used in that?
Absolutely. So we have a new project that will start soon. It's called Supernova. It's funded by the EU Commission, and we are also going to look into that. So the use of AI in finding, let's say, going through several possible configuration of your PV plant to achieve the best possible design. Also, for example, in looking at how can I design a PV plant to be friendly for robotic solution, in-field robotics and drones. So if you start combining all these elements and you start working a lot during the design phase, then you will have also benefits during the operation maintenance phase. So yeah, absolutely.
Okay, if I think, and maybe I'm dreaming a little bit too much, but imagine that with all the dynamics also on the electricity market and the pricing, negative hours, etc., becomes more and more important when the production of your solar electricity takes place, right? It's not so much, panels on the south, but so can we imagine that AI will design a plant, a surprising design, because it's based on the knowledge and the predictions on electricity market prices?
Well, let's say this can already be done, and this is something that we are actively trying to develop ourselves. But the difficult part is to predict what the energy landscape is going to be in 15, 20 years. So to design a plan that gives you the highest net present value after 10 years based on your business model, this is already possible. So it's interesting because maybe it comes out with some results, non-obvious results in utility scale PV. If, for example, your electricity is mostly valorized in the late afternoon hours, then you can imagine what the impact is on the layout of a PV plant. But the difficult part is, and maybe AI could help with that, is trying to understand what the price will be in the future. But then it's very difficult to understand due also to geopolitical reason that they are not under our control. So yes,
Yeah.
but very complicated.
Okay. Thanks, David, so far. Stay with us for after the
Yeah.
last presentation for further Q&A. And thank you so much for a very insightful presentation. Let's go to the next speaker. Leon should be there. Welcome, Leon. Yeah, Leon Overweel. He is the tech lead for solar forecasting at Dexter. And he's going to share more of the experience of what Dexter already is doing with AI. And yeah, also for you, the question, Leon, when was the first time you're a very young guy? I see on the video. When was the first time you started working with AI?
So actually, your first question made me think back a little bit, and I think the first time I sort of encountered AI was when I was 11 or 12. I was making Lego robots with Lego Mindstorms, and I was watching a video by a researcher from Microsoft who was describing how they started building the first convolutional neural networks for detecting, does this image have a cat or a dog in it? And then, yeah, sort of grew from there.
Wow, good. Take it away. The floor is yours.
Great, thank you. I'm just going to see if my control of the presentation works. Yes, perfect. Okay. Yeah, there we go. Okay, so yeah, high level, this is the agenda. I'll give some brief intros first about myself and about Dexter. And then there are 3 topics I want to cover. So how you can actually forecast solar power with AI. So this is the predictive element that David was speaking out in the previous presentation. Then how you can enhance AI with a human in the loop for data reliability. This is something that we're quite excited about. And then also some thoughts about what's next for solar and AI. Yeah, so brief intro. I went to high school in the US. My parents are still there. They set a very early alarm clock to be watching, so hi to them. I did my undergrad in Delft, and minored in AI in Singapore. Went to the University of Edinburgh to do my master's in AI. Then I worked on credit card fraud detection using machine learning as my thesis at AGEN in Amsterdam. That was very interesting. That was my first sort of look at how AI can be used in the real world. Then I focused really on deep learning research at Bloomerai, and that's what brought me eventually to my current role at Dexter, where I started as an engineer working on the wind power forecast, and now I'm leading the solar power product. Now, what we do at Dexter at a bit of a high level can be described in 3 pillars. So what I'm working on is the generation power forecasting. It's really aimed at asset owners who are responsible for selling the electricity that their solar and wind parks produce on the day-ahead electricity market. So basically, each day before noon, you need to sell the power that you're going to produce tomorrow. And to do that, you need to know for every 15 minutes, how much power am I going to produce? And if you sell more or less than what you actually produce, then you pay some imbalance costs over that. And yeah, with our generation forecasting, we hope to help reduce those. We also do flex optimization. So this is if you have a battery, we can tell you when to charge it and when to discharge it, and trade optimization, which combines these two into into a signal that can help power traders more optimally sell their power forecast or their produced power. But what I really want to dive deep into is this using AI to forecast solar power, because this is what I'm working on every day. And I thought it'd be interesting to give you a bit of a high-level overview of how we can approach this. So this is really zooming into the specific use case of, okay, I want to forecast what a solar park is going to produce tomorrow. How do I do that in the best way? It starts with training data. So to train any AI model, you need to tell it what happened in the past so that it can try to predict what's going to happen in the future. There's some basic stuff that you should know about the park. So you should know how many panels are there, what's their capacity, which direction are they facing, what is their tilt, stuff like that. Then what you need to know is historical production data. So over the past few years, every 15 minutes, what was this panel producing? Because that's what you want the model to be learning in the end. So that this is really the key thing, that you can teach your model how this solar park behaves. We also can include historical metadata, so things like availability. So maybe there was a period where the park was down for a few weeks because upgrades were happening, or there was a copper theft or something. This is something that we see surprisingly often, which is a little sad. You want to have information about that because sometimes you can detect it and then filter it out of your trained data, but sometimes also you can't. So having this kind of data really helps tell your model. The more context you can give your model, the better it's going to be at forecasting. And then the sort of key thing you need is weather models. So there are lots of organizations around the world that run weather models, where every 6 hours or every 3 hours, they're going to make a forecast of what's the weather going to be like in the next few days. Now, historically, these forecasting providers, so they're often run by governments or even by bigger organizations like the EU. They've very much focused on forecasting, for example, what are storms going to do, because those really affect people's lives. Now, more and more, you also see that these weather models are starting to be tuned to forecast renewable energy or to help companies like us forecast renewable energy because, we're installing more and more of it, and forecasting it is becoming more and more important. So we have a mix of all the sort of standard open weather models and also a couple of proprietary ones. And basically, if you take all that data, you put it into a model, and I think there we go. I won't go into too much depth about the model pipeline, but on a high level, you can do some smart things, like you can try to filter your data based on what you think is stuff that the model should be learning and stuff that the model shouldn't be learning. You can engineer features based on the physical properties of the park plus the historical production. There's a lot of cool stuff we do, and sort of day to day as researchers, this is what we try to improve. And then eventually, what we do is we post the output of those to the API of our company, and our customers connect with that API to retrieve forecasts whenever they're available. Now, what makes this quite cool, this is for me as an engineer working on this, I find this very cool, is our model, as new data comes in, it retrains every week. So we get new data from the customer, for example, for the historical production and from the weather data or whatever. And every week, automatically, the model will improve itself. And then every hour, we make a new forecast. And then all of this, we do this for thousands of parks. So basically, this entire thing you saw, you replicate it over 1,000 times or thousands of times, and that's sort of how you, and that's what we do. And for me, what's cool about this is that as a researcher, I have access to all this data, so I can try out new ideas for making the model pipeline better, and then I can see, this really works well for assets that are near mountains. Maybe this other idea works better for assets that are near the sea. Yeah, so high level, this is how you can forecast solar power with AI, or at least how we do it. Other people may have other approaches, like building one big model that'll work for all your assets, or making more of a physical approximation. But yeah, we found that this works quite well. Now, the second thing I'd like to talk about is you've got these AI models, and they can do a lot of stuff by themselves. But what we've really found is that the most valuable thing, or the most useful thing, is if you can combine the automation that AI brings you with a human who has additional context about the world, and who can also act on what the AI is telling you. So I want to highlight 3 examples. The graphics we have for these are about wind, but they apply equally to solar. Now, the first one is, this was also mentioned in the previous presentation, you can detect faulty data automatically. So you can see here that there is a huge peak in the historical production. And on the x-axis here, we're seeing time. On the y-axis, we're seeing production. And you see there's this week here that has that's way anomalous. Now, the model can detect this, of course, and it can filter it out for future training. But beyond that, it's not going to do anything with it. So what you want to do is you want to have an alert created on this, and then you want to have a human who can look into the root cause of this. So maybe the cause of this is that the customer messed up their API integration and they started sending values in kilowatts instead of kilowatt hours. Maybe there was a measurement error at the plant, or maybe there was a freak event causing more power to be pushed into their connection. So if you bring a human into the loop here, you can send the asset owner an email and ask, hey, what's going on here? And then maybe you can help them find issues that are going on with their parks or with their data. The second one is what we describe as asset level changes. So what we see quite often is that you'll have a solar park or a wind park, and it's been producing at a certain level for a long time, but then suddenly sort of the level at the maximum level at which they produce changes. This can be going down or it can be going up. If it goes down, you can have things where maybe a part of the park got disconnected because, like the example I mentioned earlier, it could be a copper theft, or it could be going up because more panels were installed. And now, if you're dealing at the scale of having hundreds or thousands of parks under your maintenance, which many of our customers are, then actually oftentimes you don't even know that this is happening. And from our perspective, if we see a trend like this in the data, it's very hard to know which situation is the normal situation and which situation may have been temporary. So maybe if you look at the right side of this graph where the production is lower, maybe a part of the park got disconnected permanently, and in the future we should be forecasting at this level. But maybe it's just an outage, and a few months from now or a few weeks from now we'll go back to this level. So this is, again, an AI can really help you detect a big change in your data. But then you need the human in the loop to be interacting with the human on the other side to ask what's going on, and which of these parts of the data should we believe and should we act on. And then the third example, there we go, is curtailment and availability data. So here again, you see a signal of a park that has where the actual production data is going down and up a lot, which is caused by curtailment. So that can be the reason for that can be commercial. So for example, if there's too much power going onto the grid, an asset owner can be paid to turn off their park. But it's a question of, if we know this is happening, we probably don't want the model to learn this, but tuning the way in which the model should respond to this signal is, again, something that we can do as a human by asking the customer, like, hey, do you want us to try to forecast when this is going to happen? Or do you want us to forecast as if you're always producing, and then you can figure out what to do with curtailment yourself? So this is, again, where if you have a human in the loop, like if you just have the model try to learn this signal, it's gonna, try to either forecast this top level or forecast this up and down. But in the end, you need a human in the loop to figure out which of those is the desired one. Yeah, so those three things are examples of how an AI that you use or AI that you use for forecasting can be enhanced with a human in the loop. And then finally, I wanted to highlight a few things that I think we can see coming soon for Solar Plus AI. And I'm really focusing here on stuff to do with forecasting. So I think the things that David mentioned, I definitely see those happening as well, but they're a bit outside of the scope of what I'm thinking about day to day. So I think mine are a bit more focused into my niche. So the first is, I think we'll see a shift from this focus on day ahead to intraday. So right now, most of the activity for a lot of the activity for trading renewable power is happening day ahead. But as more gets installed and as the forecasting also matures, I think more and more we'll need to care about forecasting small changes that are happening within the day itself and doing that very quickly. I also think that on the data side, we're going to see a shift, like because of this shift to intraday, I think we'll see a shift from NWPs, which are the numerical weather predictions, so these weather models that I mentioned at the start that are run by these big organizations, to modal fusion. So if you want to know what your solar park is going to produce 2 hours from now and not tomorrow 2 hours from now, other data sources become much more relevant. So if you have satellites, you can use them to track where clouds are and predict how they're going to move. Now, it's very hard to predict where exactly a specific cloud is going to be tomorrow, but if you see a specific cloud today and you want to know where it's going 2 hours from now, you can actually try to do that by looking at satellite images as sort of a video feed and trying to predict where is this video going to be 2 hours from now. And this is also where generative AI again comes in. Things like skycams, so this is actually the opposite. Instead of a camera on a satellite pointing down, you have cameras installed at solar parks pointing up that can look at the sky, and then you can try to see where the clouds from the perspective of the solar park are moving. And then storm tracking is also something we see, which is combining those data sources into figuring out if there's a big storm front coming, which will basically cause your solar panels to go from, maybe if it's sunny before the storm, producing a lot, to when the storm goes over, producing almost nothing. When exactly that storm is going to be above your park, that's going to become more and more important. I also think that jointly forecasting and steering assets is going to become more important. So basically, as we have more renewables, it becomes more important to sort of utilize them optimally so that not everyone is pushing all their solar power to the market at the same time. So I think just forecasting isn't going to be enough, but you also need to be steering your assets. And then finally, this is an issue we're seeing a lot in the Netherlands, and I think in the UK and in more countries in Europe, is that because renewables are growing so fast, the grids can't keep up. So what you'll see more and more is co-location of assets behind 1 meter. So you may have some wind turbines and a solar park connected to the same grid point, because typically their profiles are quite different. So you're probably not, when it's super sunny, it's usually less windy. When it's super windy, it's usually less sunny. So you can share connections. But for me as a forecaster, now I have to forecast sort of a mixed signal that has these two things going into them. So I think that's going to be a challenge for Solar Plus AI more and more in the coming years. And that actually rounds off my talk. And I think we can go to the questions.
All right. Thank you very much, Leon. Very insightful presentation as well. Well done. There are some questions coming in. Before general questions, this one for you. Is the weekly retraining and hourly forecast schedule an arbitrary choice, or is it set by some constraints such as data availability, processing power, or energy consumption? It's quite a difficult question. I don't know if you're capable of answering, or do you
No,
understand the question from Christian?
it's a very good question. The weekly retraining, we basically tested a few things. We tested training monthly, training every 2 weeks, training every day, and we found that the training is quite expensive indeed in terms of energy, like energy use of the actual computers doing the training. And we found that sort of the gains of retraining more often, going from monthly to weekly, they're quite high, but then going from weekly to daily, they're very minimal. So then it's not worth it. The hourly running is mostly based on how often new data becomes available. So these weather models, they run every 3 or 6 hours, and then approximately around every hour we get a new run from at least one of them. So that's how we got to running hourly.
Okay, great. Another question for you. Can you elaborate a bit more on how well AI for solar forecasting can be used in different geographical areas?
Yeah, so it really depends on the input data and the geography. So these weather models that we use, some of them have global coverage, but some of the most high resolution one have very local coverage and are tuned for specific geographies. So for example, in the Netherlands, the KNMI runs their own model, which is really tuned to the Netherlands. So then in the Netherlands, you'll do slightly better because you have access to this additional weather signal. And then also geographies, like if you're in the mountains, you need to account for the shadows that are cast by mountains, for example. So if you're not accounting for that, you're not going to do well in the mountains.
Yeah, makes sense. Question here as well from Amir Abdallah. He says, Leon, what is the minimum set of data needed to have a reliable model for prediction and forecasting?
Yeah, so what we see is if you're looking at thousands of parks, you really see there's a big diversity in the quality and the amount of data that's available. So what we do is our model becomes progressively more complex as more types of data, like all the ones I mentioned, and a higher volume of data is available. So we can actually also make a forecast that's pretty okay with no historical data and just basing it on the location, the orientation of the panels, and the installed capacity. But really, as more data comes in, the model gets better.
Yeah. Final question for now for you, and maybe also then for David. How can we mitigate the risks of low data quality from operational PV plants?
Yeah, sorry, I'm getting kicked out of my hotel room, so maybe I can take this question later.
Okay, well, let's see if David can answer it. In the meantime, David, how can we mitigate the risk of low data quality?
Well, let's say low data quality depends on the sensor and the data logging system that you have. So the good thing of AI will be able to understand if the data is coming from low quality data. It's not that AI just takes something and spits out some results without, let me use the verb, thinking what it's doing. So it's mimicking the same way we will be looking at data. We will be looking at data. We will see that there is something wrong. We will identify that this error is due to low quality, and we will react upon it. And I think that this workflow can, in principle, in the future, can be entirely done and driven by AI.
Yep. I'm not sure if Leon will come back, but maybe Wahbe, you, as you are still around, I hope. I was wondering, and maybe for all of you, the question. So, Leon, you showed like the models, like for energy trading, day ahead, intraday. Now, suppose in an ideal world, all of the producers in the asset owners will use your predictive models. So everybody has the same information and it makes the analysis, and everybody sees like, oh, this time we shouldn't produce because, or we should be curtailed, or we should curtail our plan. How is the market going to respond if everybody is so predictable because everybody's using AI? Is that going to disrupt the system?
Yeah, so if everyone is following the same signal, of course you're going to you're always wrong, right? It's just about being slightly less wrong than everyone else. So indeed, if everyone is following the same signal, you're going to be flipping the market back and forth, and then indeed you get chaos. So actually, this is why our flexibility and our trade optimization products, we also we look at the market impact that they could potentially have, and we only actually sell them to a very limited amount of people in each market, so that we can limit how much volume is actually shifting around based on our signal. Because we also know that if everyone just starts doing the same thing, then you're all going to be wrong in the same way at the same time, and then it doesn't work. So yeah, you always need a bit of diversity.
Did you see, Wahbe, do you see this also in the financial world? Let's say the stock market, the traders, I guess they will also use AI.
Yeah, I think at some point you will have these general models that a lot of companies will use. But just to add on that, even though every company can use the same model, it's in the end also about how you use it, right, and how you act on it. So if everybody has PowerPoint, not everybody makes the same PowerPoint presentation, right? So it also counts to the same for these kind of models. So it's also about how you use it. And this is going to affect every sector. So we will see dedicated models for different sectors, but in the end, it's about your company, how you're going to use it, and act on the data that flows out of those models.
Yeah. Looking at the time, couple of minutes left. I also have a general question, maybe for all of you to answer. So, where do you see in the near future that most of the developments will happen, and impacting then also potentially the solar industry? So we talked about reporting, the data analysis, the interpretation of images, the generative part of AI. Well, where do you see the biggest changes and the biggest developments happening that could potentially impact also solar? Maybe let's do it one by one. Let's start with you, David.
So it's a difficult question to predict which part of the solar sector will be mostly affected or will mostly benefit from AI. Maybe I would, instead of answering your question, I would maybe ask people in the industry to instead of holding on their business model as usual, to try to understand how AI can disrupt the way things are done at the moment. So that would be my suggestion, and then we will see, let's say, really new things emerging in the sector.
Okay, well, we have a slider question coming up, but maybe first ask Leon and Wahbe for their opinion on this. Where do you see the biggest developments happening right now? Leon?
Yeah, so actually maybe very much from my perspective, and it's a bit broader than solar, but as someone who's developing software products, I'm doing this for solar power, but this is happening all across the industry. We've really seen a step change in the last half year, maybe, of using generative AI as a coding assistant. Like, I'm becoming so much more productive when I'm like writing the start of a function and I already have in my head what I want it to do. And instead of spending 10 minutes writing it, I just click tab because the coding assistant also understood what I was trying to write. So I think things like this, just everyone becoming more efficient in their work, is also going to be affect software in solar, but also affect software everywhere else.
Great. Yeah, I can imagine. Wahbe, what's your opinion?
Yeah, I actually totally agree with Leon. We talked today a lot about predictive models, right? To predict the amount of energy and the price of energy. But I think what we've seen in the past months, and that will probably continue in the next few months, is that more and more people will start using AI as a co-pilot, as an assistant, which will help us improve our productivity. Whether you are an office worker or you are in operations, there are so many AI tools and AI applications that you can use to save time. And by saving time, we are able to come up with new ideas and have room for further developments. And I think that is the biggest impact that we'll see of AI in the near future.
Okay. Great answers. Maybe Bo, can we bring up that final poll question, and then we can round off this nice webinar. So, looking at the topics regarding AI, what do you, as a participant of this webinar, see as worth learning more about, and if we would organize a more dedicated conference about this topic, the impact of AI on solar. So please, if you share your answer with us, that will help us as well as Solarplaza to see if there is any appetite for a specific conference dedicated to the AI impact and what kind of topics we should then address during this event. And I see most of the answers still going to data optimization, forecasting, and analytics. And I know from our previous conferences, like in Frankfurt on asset management, there is already a lot happening in data optimization. It's not really a surprise. Also cool to see some people. AI in general, ChatGPT, I can underline and I can fully acknowledge that also in our company, we're working more and more with that as an assistant, indeed, to help us, for instance, do some market research. So not a surprise. Good. I would like to thank you for your cooperation. I would like to thank the speakers, David, Leon, Wahbe, for their very insightful presentations. Thank you very much on behalf of all the participants. I hope we can see some of you at participating in some of our new upcoming events in the near future. And I think, if I don't forget anything, Bo, thank you all, and I hope to see you next time. Bye-bye.